All right, the second example we're going to look at is one in which we're going to look at a first order phase transition. In other words, if we are dealing with this particular problem, what we want to know is given that we have 1 kilogram of ice, 1,000 watts of power delivered to it, and the latent heat of fusion, in other words, how much energy or how much thermal energy Q here it's going to be required to melt it. What we could figure out is how long will it take this burner to melt our ice here. So you can do this in a number of different ways. However, we are told how much ice we have, and we're told the latent heat of fusion. In other words, what we can do right away is we can figure out how much thermal energy, or Q, and this is of course the change in thermal energy, so let's give it a delta, that we need to enact this phase transition. Now, first order phase transitions, they are pretty straightforward. What we're going to do is we're just going to take our mass, which is 1 kilogram, and we're going to multiply this by the latent heat of melting. So 334,000 joules per kilogram. And this is going to tell us exactly how much energy or thermal energy we need to provide to our system here in order to enact this change. So first order phase transitions, actually let's put the J up here, are nothing for you to be intimidated by. They're a change in energy just like anything else, and you can figure them out literally by just taking the mass that you're planning on changing and multiplying it by the latent heat of fusion. Now, the second question is we're not exactly asked how much energy we need, but given this power that we have, what we want to do is we want to figure out how much time we're going to need. And how you deal with this is you deal with it in terms of power. So power simply tells you the amount of energy that you're giving something per unit time t. Now, with this, we can actually figure out exactly how long this thing is going to take. Because we're told we have 1,000 watts of power, we've just determined how much energy we need to provide the system with. And our goal here is to find the time over which this change in energy must occur. So basically all we do is we take this power equation, we can just rearrange it to solve for the time. The time is going to be the amount of energy we need in joules divided by the power in watts, and this will give us a time in seconds. So if you do this, what you will find is that this is going to take about 334 seconds to occur. So typically speaking, these are going to be types of energy, just like everything else. The only difference is, in this particular case, for forced order phase transitions, they're actually quite straightforward to determine.